For the fourth part of this lecture, I'm going to move on the outline to Roman numeral number 5, the Taussman speed reading program. This is just contrived, but hopefully it'll teach you another example here. Let's say we know that adults read about 150 words per minute. Sigma, a Greek symbol, is 100, the standard D. Let's say I'm conducting some research on my new Taussman speed reading course to get people to read quicker. I'm working at a large state university. I recruit 10,000 adults into my program, and they are reading, after they go through my Taussman speed reading course, 150 words, 153 words per minute. So first it says, please choose the relevant statistical analysis and do it. What is your statistical and real-world conclusion? And then the next question, would you pay $1,000 for your spouse to take the program? And describe this situation. So let's start off here. First, the question is, what would be the relevant statistic to use to evaluate this? Well, sentence 1 is the key. You know that adults read 150 words per minute. Hopefully you were able to figure out that information, that's a mu value. That's population information. Sigma at 100 is also population information. If you know stuff about the population, what statistic could you use? Hopefully you would figure out that you could use the z-test. So z equals what? X bar minus mu over sigma divided by the square root of n. What's x bar? Well, x bar is the score after my program. 153 minus what? Well, the mean is 150, so the numerator is 3. How about the denominator? The denominator, well, the standard deviation, sigma, is 100 divided by the square root of n. Well, what's n? 10,000 adults. Well, the square root of 10,000 is 100. So if you put 100 over 100, the standard error of the mean is 1. So you get a final z-score obtained of 3. Do you remember what the critical score is? It's 1.96. So would this result be significant? Yes. So think about that for just a second. That score is statistically significant. So you'd have to say, hey, the Taussman program really works. People are improved statistically when they take my program. So that should be pretty straightforward for you. But the question is, would you pay $1,000 for your spouse to take this program, or would you even be happy yourself if you were reading at 153 words per minute? Hopefully you would answer what? No. Why would you answer no? Well, hopefully you would answer no because you would need to look at the treatment effect here. This treatment effect is only 3 points. Is 3 points anything in statistics? No. Well, is 3 points anything, I should say, in reading? No. In reading, if you can only read 3 more words per minute, that really doesn't mean anything to people. And so in this particular situation, you are reading a tiny bit better, but how come this tiny result is significant? Well, it's the sample size. You got 10,000 people to be part of this study. And part of the problem of statistics is that if you get 10,000 people to do anything, you could show anything to be statistically significant. So this is one of those cases where something is statistically significant, probably in the real world it's not so important. So if you were actually to go back to that state of affairs table, you collected data here, you said the result is statistically significant, you'd like to think your program really helps people, but there's a good chance this could even be a false alarm, that this is statistically significant, but in the real world, not so significant. You might have a false alarm here. So you've got to be really careful here with type 1 errors, like I'm talking about here, where you're saying something is significant, but it isn't. So don't just assume that if something is statistically significant, it's also significant in the real world. And this example should help illustrate that. Thanks.